So now we're going to talk about biological theories of dreaming. So later on, after you're done with this video, there's a short little activity that will take you through two other videos. One will talk about theories of why we sleep, and the other one will talk about theories of dreaming. But these are specifically the biological theories of dreaming. So what happens in the brain that causes us to have the dreams that we have? And so we're going to talk about two of them that are discussed in your textbook. The activation synthesis hypothesis and the clinico-anatomical hypothesis. So we're going to talk about two of them that are discussed in your textbook, the activation synthesis hypothesis and the clinico-anatomical hypothesis. So the activation synthesis hypothesis says that dreams begin with those PGO waves. And where do those PGO waves start? With spontaneous activity in the pons. And remember, those pons are going to be inhibiting our postural muscles. And a lot of times in our dreams, we have this feeling that we have this inability to move. And that's a common theme in dreams. Also, those pons are going to be stimulating other parts of the brain, in particular that cortex. And so when you're activating many parts of the cortex feels this need, this is the part of the theory, to synthesize that into forming a pattern. And that's why the stories don't always make sense, because we have these different parts of the brain that are being activated, and then it just synthesizes a story from that. So again, that's the activation synthesis hypothesis. The clinico-anatomical hypothesis has less emphasis on the pons in REM sleep, because remember, not all of our dreaming occurs during REM sleep. But it suggests that dreams begin with arousing stimuli that are just generated within the brain. As we're sleeping, we still have input from our senses. We can still hear things and smell things like that. And the parietal cortex is highly active, if you remember that from one of those previous slides that we talked about. And that activity combined with recent memories then gets synthesized into a dream. So stimulation from the environment combined with our recent memories gets synthesized into a dream. And so evidence to support this clinical anatomical hypothesis is that we have activity that is high in the inferior parietal cortex, which is important for visual spatial information. So if you remember earlier, in an earlier video, we talked about how this parietal cortex has a lot of activity, especially in REM sleep. We also have activity in the prefrontal cortex being suppressed. I also mentioned that this might become important when we talked about dreaming. So if you think about, when we get to the memory section, we'll talk more about how the hippocampus is important storing memories, but we think that eventually those memories get moved into the prefrontal cortex. So if you have activity of this area being suppressed, that could be why it's difficult to remember these dreams once we wake up. We also have activity high in the hypothalamus and amygdala. And do we remember what this amygdala is important in? Emotions, right? And so in the hypothalamus, it drives that are vital to survival. So that's why a lot of times our dreams have this very emotional content to them. So that activity accounts for the emotional activity and the motivational content of our dreams. So that concludes this video. Now you'll go on and do the lucid dreaming activity. There's a couple other videos for you to watch, a little assignment for you to do on the theories of why we sleep and the theories of why we dream. And then you'll finish up this module with a Kahoot on sleep disorders. All right?